This is Suvarchala, working as an associate professor in the Institute of Aeronautical Engineering. In this session, I would like to define some terms related to transaction processing, concurrency control, that is concurrent transactions, and any transaction failure occurs, how recovery takes place. The terms and definitions related to these areas and certain basic terms related to query processing will be discussed here in this lecture. So first I introduce the transaction processing terms. First one, what is transaction? So the execution of any program that either access or changes the database contents is called as a transaction. So what is a transaction means? It's a unit of operation. We can say that. For example, we are transferring fund from account A to account B, one transaction. For example, I would like to update my balance, another transaction. So transaction means a unit operation which will be represented by using some set of instructions actually. So when these transactions are executing, depending upon the type of the system, type of the database we are using, this processing is going to be carried out. So the system may be a single user system or a multi-user system. Single user system means at most one user at a time can use your system, then it is single user system. For example, your desktop, your laptops, your own personal PCs, etc. Multi-user system means the systems which are connected with through some local area network or wide area network, etc. So concurrency, when multiple users are using the system, even not only system means even they are going to access, multiple users will access a database from your server. They may access other devices, permission, depending upon the permission, etc., other devices. So then automatically multiple users are using the system. Some techniques we have to follow system supposed to follow to attend their operations properly. So multiple users are working means system is going to be utilized by multiple users concurrently. The system may be your database, or the system may be your computer system, your memory, etc. So that means concurrently. What is meant by concurrency? Concurrency means simultaneous accessing. Concurrently means simultaneous accessing. While doing this concurrency, the processing, there are two ways will be there. Processing are not going to be weighted. One person submitting one operation, one process, let us assume that, then automatically other people need not wait till this process get completes. What happens? Other people will get fatigued and they may not submit any operations at all actually. So that's why system always supposed to attend all users very frequently so that users should not feel that your system is not responding for them actually. For that purpose, the system works in case of multi-user environment, interleaved processing, parallel or a simultaneous processing. Interleaving processing means the concurrent execution of process is interleaving process. The concurrent execution of process will be interleaved. Interleaved means some process is going on, it will stop and another process may again start like that. Stop means not wantedly. For example, some process is some output operations are performing. Then IO operations are performing means IO devices related software is going to be, or IO related instructions are going to be executed. Till then CPU will be idle, no? So that CPU will attend some other process actually. Like that, some operations are going to be interleaved actually. The process are going to be interleaved in a single CPU. And in case of parallel or a simultaneous processing means multiple processors will be there. The processors are going to be concurrently executed in multiple CPUs. So when the concurrent processors are there, It may be interleaving or it may be parallel or simultaneous depending upon the CPUs, number of CPUs available. So what is a transaction? We define transaction as a unit of program execution that access and possibly updates various data items. Generally, when transactions are executing, those are simultaneous transactions in database management systems, because that is the basic definition of database. We defined simultaneous users, we considered the word. So that's why two main issues deal with our transactions are the transaction may get failed or may get completed successfully. If it get fails, what happens? That means when the concurrent execution of multiple transactions are executing, if it get fails, we have to take care of something. Partially, it updated our database, which may not make our a database in a consistent state. So that's why it is a unit of program, but we supposed to see that the transaction must completely get executed, or none of the operations of the transactions executed. We'll define those terms. So these transactions are various types. Serial transaction, two or more transactions are processed in serial fashion, means one by one those are going to be executed. Interleaved transaction, interleaved processing I explained, similar to that. Interleaving transaction means two or more transactions are processed concurrently with one transaction at a time actually making progress actually. But this most oftenly occurs on a single multi-programming CPUs. Single CPU will be there, but multiple programs are going to be processed. There, this type of interleaving of operations exists. Third kind of transactions are simultaneous transactions. Two or more transactions are processed concurrently with any number of any number of transactions are progressing. That is, it will have multiple CPUs. Each CPU will take some transaction. Whenever we are using the transactions in our database management system, we supposed to use two terms generally. We will use very frequently. Commit transaction, rollback. Commit means here, whatever the operations we performed on transactions, those are going to be permanently written into the secondary storage device. That is, those are written back to our database actually. So commit means it signals that successful completion of the transaction. Commit signals the successful completion. Commit means permanent. Whatever the updates are made by the transactions, till then those are going to be in buffer. Those are going to be carried out permanently in our secondary storage device, that is the database. Then we will call it as a commit. Commit means permanently updation of the whatever updates are happened in our transaction are done permanently. And also it indicates that successful completion of the transaction. Another word we will use, abort the transaction or a rollback. Abort means it signals the transaction has ended unsuccessfully. Maybe reasons, various reasons may be there. Because of logic or because of transaction failure, because of system failure, whatever may be the failure. The transaction was not completed successfully. Then we will get a signal as a system will get a signal as a transaction aborted. That is not successful, no, but partially it happened. So that's why any changes or effects on the transaction are performed up to then, those must be go back to their initial position. That means those must be undone. So this rollback or abort, rollback means undone. Whatever the operations are performed by the transaction till then, that is signal unsuccessful, no? So that's why till then, those operations are going to be undone. We will make our database into a initial stages. Initial stages means before the transaction starts, whatever the stage of database is there to that database. So a transaction signals abort means completed unsuccessfully, ended unsuccessfully, in other words. So that's why in such cases rollback happens, that is undoing the operations performed by the failure transactions. So any failure occurs, as I told you, undone. Undone means undo. So during any failure of the transaction occurs or any failure, system failure occurs, Whatever the transactions are ongoing at that time, some of them are completed, some of them are not completed, partially completed, etc. So in such cases, how the data is going to be recovered? As I told you, transactions are undone and they must go back to the initial stage of the database. That is, before transaction, what is the stage of database is there? That. To do this process, two small operations are going to be performed. So what are those operations? Undo operation, redo operation. So what is an undo operation? Undo operation is similar to the rollback. But what is this? It applies to a single operation rather than the whole transaction. Rollback applies entire transaction. Undo applies a single operation. That means if rollback is there means multiple undo operations have to be done. What is redo operation? Redo operation means if the transaction operations must be redone to ensure that all operations of committed transactions have been applied successfully to the database. And when a transaction processing we are discussing, all of us supposed to aware of the acid properties. Acid properties are the desired properties of any transaction. Acid stands for A for atomicity, C for consistency, and I for isolation, and D for durability. Acid stands for acid properties means atomicity, consistency, isolation, and durability properties. This atomicity property, what is it? A transaction must be atomic. Atomicity means a transaction must be atomic. That is, a transaction must be an atomic unit of processing. What is meant by atomic? Either the transaction performed in its entirely complete transaction has to be performed, or should not perform any of the operations of the transaction. All operations must be performed, or neither of the operations must be performed. That means not partially. So what is atomicity? Atomicity means a transaction must be, all operations of transaction must be performed completely, or none of the operations must be performed. It means that the transaction must be successfully completed. If any failure occurs, the transaction has to go back to the initial, make your database as a before transaction, what is the state that has to be. Consistency preservation. Consistency preservation means the correctness of the execution of operations of the transaction. That means a correct execution of transaction must take the database from one consistent state to the another consistent state. Consistency I defined already. So consistency means correctness. So if the transaction completes successfully, previously before transaction, it is the database in consistent state. Again, it will move to the consistent state only. That means must be preserved by our transaction. If it get failed, what happens? Part of the database was updated, which it may lead to some problems. So that's why we have to make a rollback process actually. And the third one, isolation. Isolation means a transaction should not make this update visible to the other transactions until it committed. I am working, for example, I am booking for a reservation from a railway reservation. Many people are also doing no, but I don't know or I am not aware of who are using this reservation and who are for which trains they are reserving. All this information is unaware to me. As a user, I feel that the reservation system is working for me only. So what is isolation? A transaction should not make its updates visible to the other transaction until it is going to be committed. This property is enforced very strictly so that it solves the temporary update problems and makes cascading rollbacks of transactions unnecessary. These are all going to be solved if this isolation is going to be assured. Next, durability. Durability means permanently. Durable means permanent. Once the transaction changes the database, the changes must be committed in. Committed means Those are going to be permanently stored in our secondary storage device. These changes should not get lost based upon the subsequent failure. For example, I'll give small example. I have withdrawn some amount from, or I transferred some amount from my account to other account. Okay, transaction happened, completed. After 1 hour or 2 hours, system get failed. Again, this transaction should not be recovered because already it committed, no? So that means durability, means permanently updated. The amount was deducted from my account, amount was added to other account also. Completed. Once completed, permanently the updations are carried out. Those should not again last because of the subsequent failures. During the process, any failure occurs, it's different. Once completed, then the changes made to our database must be permanent actually. Right? So when these transactions are executing concurrently, we will use various kinds of scheduling these transactions. So we'll define some terms related to these concurrent transactions schedules. What is a schedule actually? Schedule means interleaving of actions of different transactions. As we discussed earlier, 2 or more transactions are executing parallelly, even single CPU is there. Then some of the operations are performed one transaction, some other operations of the other transactions are performed, etc. depending upon the IO operations, depending upon the CPU related operations, etc. So that's why in such cases, these instructions are going to be interleaved. These transactions are interleaved means these instructions or actions are going to be interleaved. Such a way that because we cannot, one transaction cannot wait to other transaction completes, then it will start. If that is the case, no, if a beginning a large transaction is available, long time duration transaction, with the transaction which is having very small number of instruction has to wait till this completes. But remember, whenever a schedule is there, schedule means interleaving of the actions of different transactions. Serial schedule means a schedule that does not interleave the actions of different transactions. As I told you, first T1, next T2, next T3, serially. Equivalent schedule means for any database state, the execution of the first schedule is identical to the effect of the executing of the second schedule. That means here, non-serial. Serial schedule I defined. Non-serial schedule means interleaving operations. Any non-serial schedule can convert into an equivalent of any serial schedule. Then we can say equivalence schedule. Both are equivalent, you can say. Serializable schedule. Serializable schedule means the schedule that equivalent to some of the serial schedules execution of the transaction. Then we can say it is a serializable schedule. Even though those are interleaving operations are available, we can able to convert into any one of the serial equivalent serial schedule. Then we can say the schedule is serializable schedule. So if the schedule is serializable, then automatically it preserves consistency actually. So every serializable schedule preserves consistency. So one of the properties base properties of transaction is consistency. So consistency is considered. Schedule is a sequence of instructions that specify the chronological order, first which one, second, like that. Chronological order in which the instructions of concurrent transactions are executed. And it is a set of transactions must consist of all instructions of all those transactions. And it preserves some order in which the instructions appear in each individual instructions. If instructions are interleaved, what happens? And we're supposed to check whether that particular set of instructions, interleaving of instructions, are equivalent to some serial schedules or not. To do that, to prove that, we have to interchange some operations or some instructions. So for that, first we need to know conflicting instructions. Which instructions are known as conflicting instructions? Let Li, Lj be two instructions of the two transactions Ti, Tj. Two transactions we are taking. Li is related to Ti and Lj is related to 2. If those two instructions are there, two transactions are executing interleavingly, Ti, Tj, let us assume that. If Li, Lj are there, we will say Li, Lj are conflict if any one of these four properties are going to be satisfied. What is the properties? If both instructions are LILJ, both instructions are reading the same data item, no problem. The order of the instructions is not a problem at all. That is, don't conflict. One of them is right or two of them are also right, then the instructions are said to be conflict instructions. Conflict instructions cannot be interchangeable. That's why we have to find out conflicting instructions. What is meant by conflict? If two instructions of two transactions we are considering, if those two instructions are performing some IO operations on same data item, then both may be read, then those are not conflict, but any one of them, at least one of them is right statement on the same data item, no? So that's why updating actually. It's a conflict instruction. So if any schedule S and which is equivalent to some of the serial schedule, conflict equivalent we will call it as. We say that schedule S is conflict serializable if it is conflict equivalent to any serial schedule. That is, by applying this conflict instructions, non-conflict instructions are there, we can interchange them because of this swapping of instructions according to the chronological order swapping. We discussed already all these things in transaction processing, may result a serial schedule. So that is conflict equivalent means if S is a schedule S can be transformed into a serial schedule S dash by a series of swapping of non-conflict instructions. We will call this S and S dash are conflict equivalent. Then S is known as conflict serializable action. Next, precedence graph we will define. What is precedence graph? Precedence graph is used to here to check whether the transactions are having any conflict instructions or not actually. So for example, schedule of transactions T1, T2, etc. Tn are there. Precedence graph is a graph where the vertices are transactions itself, names, and arcs are going to be drawn from a transaction Ti to Tj if the two transactions are conflict. That is, Ti is accessing the data which is updated by Tj. Then there will be an arc from Ti to Tj. And we label these arcs by the data item on which the arc was generated. So precedence graph. Precedence graph means a graph consists of nodes. Each node is a transaction it represents, and these nodes are connected by some arcs such that if there is a transaction Ti is using the data which is updated by Tj, then there will be an arc from Ti to Tj. When a purpose of precedence graph is if any precedence graph, a cycle forms, then it is a conflicting schedules. We cannot equivalence. Some instructions are conflict actually. And view serializability. What is view serializability? A schedule S is view serializable if it is view equivalent to the serial schedule. So a schedule S is said to be view serializable if it is view equivalent actually. Schedule transactions, various types of schedules we will call. Recoverable schedules, cascading rollbacks, cascadeless schedules. Recoverable schedules means if any transaction Tj reads a data item previously written by some other transaction Ti, then commit operation of Ti must appear before commit operation of Tj. Because Tj is using Ti updated the data, no? So that's why TI must be committed first. Then TJ will be committed. So that what happens, any problem occurs TI, it may not get reflect hours. Cascading rollbacks means any single transaction get fails. Depending upon that, a series of transactions have to be rolled back. We will call them as a cascading rollbacks. A single transaction failure leads to a series of transactions to be get rolled back. We will call it as a cascading rollback. Cascadeless schedules. Cascadeless schedule means each pair of transactions TI TJ such that TJ reads the data item previously written by TI. The commit of operation of TI appears before the commit of operation of TJ so that there is no any cascading rollbacks. And various techniques we will follow to avoid these type of more rollbacks actually. One of the technique is two-phase locking technique. What is two-phase locking technique means? This locking technique, the operations, a system will provide some permissions and read-write operations because the problems with such type of cascading rollbacks, etc. are occurs because of accepting or accessing the data updated by some other transaction. That means read and write operations. So that's why two-phase locking means the locks are going to be provided on data items on read and write privileges are performed or allocated on data items to various transactions. We will call it as a logs. Privileges means here locking. So allowed locking are for reading, lock is allowed. For writing also locking allowed. That means for updation and reading. In case of two-phase operation or two-phase locking, permissions are going to be provided to read. Permissions are going to be provided to write data item in the second phase actually. We'll call it as a growing phase and a shrinking phase. Growing phase means only providing the locks on the data items. Shrinking phase means releasing the locks from the data items actually. So what is meant by locks actually? Various types of locks are there. Locks are nothing but just we are giving permissions to them. System will provide permissions. Two kinds of locks are going to be provided. Exclusive locks and shared locks. Exclusive lock means the lock provided on exclusive locks, the transaction can read as well as update. Transaction can read as well as write. Operations are performed. Shared lock means the transaction can perform on those items only reading but not writing. Updations are not allowed. So lock requests are generally made by the concurrency control manager, implemented by the concurrency control manager, which are requested by the programmer. Transaction can proceed only after request is granted. So as we discussed earlier, two-phase locking protocol consists of the two phases. One is growing phases. Transaction keeping on accepting or obtaining the locks only. It won't release. Once it started release means it enter into the second phase, shrinking phase actually. And this two-phase locking protocol will be having various variations. In case of basic, only locks are provided, growing phase and shrinking phase. Conservative means to prevent our deadlock, all desired data items are first initially, just like declaration section initially, even all locks. Till the transaction completes, the locks are not going to be get released. Conservative actually, that is. What is a deadlock? Deadlock means here, a transaction is waiting, for example, a transaction TI is waiting an item X, which is already obtained a lock by TJ. Another transaction, this TJ is waiting for a lock on Y, which was already obtained an exclusive lock by T. That means TJ is waiting till the TI releases the lock on Ty, whereas Ti is waiting for getting a lock on X, which is imposed by Tj. Both may not release the locks since those are both are on the growing phase only. That means both are in deadlock situation. It won't release, this one also no. So that means a system is in deadlock if there is a set of transactions such that every transaction in the set is waiting for the another transaction in the set to be get complete or release the locks. How can you prevent? Various protocols are there. That means ensure that system will never enter into a deadlock. We are going to pre-declaration protocol is there. Similarly, graph-based protocols are also there. And some of the schemes are there to prevent this deadlock situation actually. Wait and die. Wait and die means it will wait. So in such cases, which of the transaction has to be stopped first? Whichever is the older transaction, that will be stopped. The older transaction may wait for younger transaction to release the data item. Younger transaction never wait for the older transaction. That means younger transactions are going to be rolled back. Older transactions have been done lot of work, maybe. And wounded wait will be there. Preemptive this is. Preemptive means the older transaction forces to get rolled back. And younger transaction will get respective locks. And a combination of these two can also be used. Then what is starvation? Starvation occurs when a particular transaction consistently waiting or restarted and never gets a chance to proceed further. We will call that particular transaction is in starvation. Starvation because of any of these reasons, deadlocking or wait and die or wound and die, etc. Based upon these things, a transaction may be always enter into the process and it will wait consistently, and again it got rolled back and again started, again got rolled back, etc. That means it is not at all getting a chance to complete, no? So we will call it as that situation is the respective transaction in this starvation case. In deadlock resolution, it is possible sometimes the transactions are victims and keeping on continuously get rolled back. Theirs are in starvation. Now we'll discuss some terminology related to our storage structures. Volatile storage and examples are main memory. What is meant by volatile storage? The storage does not survive system crashes. That is, it's not permanent. Non-volatile survives system crashes. That means the data was stored permanently. Example, disk, tape, flash memory, etc. Sometimes still it may be possibility of failing of the secondary storage devices also and possibility of losing data. But non-volatile means permanent storage. Volatile is temporary storage. Main memory, etc. Flash, cache memory, etc. Stable storage, sometimes in mythical form of storage that survives all kinds of failures by maintaining the multiple copies on distinct non-volatile media. While accessing the data, we will use two terms, physical blocks and buffer blocks. Physical blocks are those blocks residing on the secondary storage device. Buffer blocks are the blocks residing on the temporary storage device. And blocks are going to be moved by using because of this input and output statements. Whenever a recovery algorithm is used, redo phase, undo phase will be there. Redo phase means repeating the same instruction. Undo phase means undo all incomplete transactions. So how to do this redo phase, how to do this undo phase are by using logs. What is a log? Logs are some records. Two types of records will be maintained by the database management system in a stable storage, permanent storage actually. So what are these logs actually? These logs are of the two types, transaction records and system records. Transaction records are useful to do either redo or undo process actually. System records are useful for us up to which point this type of redo undo process has to be considered. That means the transaction records means begin, insert, delete, update, commit, abort, all these are transaction records. System records means checkpoint, dump, etc. What is checkpoint? Checkpoint is some location, a record, log record. Up to that, the recovery process completed or active transactions are completed. So based upon this checkpoint, the redo, undo operations are performed. Not entire thing every time. Up to that particular checkpoint only the process is continued. Dump means dump is a copy of entire state of database which will store. We will take dump for recovery process generally. And this physical storage media is going to be classified as volatile, non-volatile storage, which we discussed earlier, and RAID is another kind. What is RAID? RAID stands for redundant array of independent disks. Multiple number of disks are going to be stored as considered as a single disk, which will have high capacity, high speed, and will store or do the multiple tasks in parallel. High reliability also. So most of the time to dump as well as secondary feed backups are going to be stored in RAID actually. And the data in our database is going to be stored in the form of files, that is collection of files. Of course, these files are integrated and all database related characteristics are going to be introduced, but the base structure is files. Each file is a sequence of records, that is tuples in our database terminology, and each record is a sequence of fields. In our case, a tuple is a sequence of attributes. So these records may be fixed size or variable size. We will call it as a fixed record size, fixed records and variable record sizes. Fixed means the length of each record in the file is same. Variable means the length of each record are different actually. How this data will be stored in the files and the arrangement of these records or tuples in a file is known as organization. What is organization means? Arrangement of the records in our file is arrangement as well as the managing is known as organization of the records. Various organizations are available to us. Heap organization. In case of heap organization, a record can be placed anywhere. Wherever place is there, you can place. There is no any rule. It must be in order or etc. Sequential organization. The records are stored one by one. Sequential order based on some of the search key. Hashing means it computes the hash function will be there. It computes on some attribute of each record and the result will give the address of the physical space where the record was stored. Right? And records are stored and can be accessed through blocks by using buffering concept. Buffer means the portion of main memory available to store copies of the disk block. Buffer means portion of main memory available in to store the copies of whenever the data copied from disk, it will be stored in the buffer. Buffer manager will take care of how the transfer of data must be done among these secondary storage and buffer. So how much memory should be allocated, etc. Another kind of file organization, ISAM. ISAM stands for Indexed Sequential Access Method. When the data or a file is stored by using index file organization, then ISAM is needed. Index file means an index file is created for our main file, which consists of two attributes, search key and address of the record. So like this, search key and a pointer. Pointer is nothing but an address of the record where it actually stores. The collection of these two fields are called as a index entries. Index file consists of records of the form only two attributes. On a particular key, I created index means on a particular key value, I will have this. The respective original record where it was stored will be stored pointer. These indices are of the various types. Ordered index, that is index entries are in a sorted order. Primary index in a sequential ordered file. The search key specify the sequential order of the file. This is also known as clustering index. Secondary index, if the same first index is same, then it will be on the secondary index. Ordered sequential files with the primary index is known as indexed sequential file. Dense index means index records, there will be one index record for each physical record is there, then we will call it as a dense index. Sparse means one index record for a group of physical records is a sparse index. This indexing can also be done, some B tree indexing structure also considered. One of the best example for B plus tree. B plus tree means the indices are an alternative to indexed sequential files. Key values are arranged in the form of tree and each node consists of pairs of values, that is key and values depending upon the size of the node. Hashed files, and the data can be stored by using hashing technique. Hashing for disk files is called as a external hashing, and hashing we are going to done for our internal memories space management is known as internal hashing. In case of hashing, we will use bucket. What is bucket means? Bucket is a block of memory having equal sizes. So M buckets are there, all of them will have equal size depending upon the size of the bucket. And one of the hash key will be there. Hash key means on a particular attribute or a set of attributes, this hash function is applied to get the address of the respective record is known as hash key. What is a hash function? There will be a mapping between the key and address of the bucket through some function. That function is known as hash key. That is, if the bucket number is I is equal to h of k, h is the hash function, k is the key value. So that's why, what is a bucket? Bucket is a unit storage containing one or more records. Hash file organization is storage of data in secondary storage directly mapping with the hash address technique using hash function. And if the buckets are not sufficient, more buckets are added. So that is known as overflow chaining. Overflow chaining means the overflow buckets of a given bucket are chained together in a linked list. In such cases, new buckets are not able to add it. No, that means 4 buckets, depending upon the hash function, 4 or 5 buckets, the address will be there. So that's why such type of hashing is known as closed hashing. That is, fixed number of bucket addresses will be there. Alternatively, open hashing will be there, which does not use overflow bucket. It is suitable for the database applications where the database is frequently going and shrinking there. What is dynamic hashing? The function is going to be static hashing if it will have fixed number of results of bucket numbers on applying hash function. Dynamic hashing means here it's keeping on changing. That means depending upon the size of the database, the addresses of the buckets can be varied. It may be decreased or it may be reduced. One of the example is extendable hashing function. These are some of the definitions related to transaction processing and storage of the data in our database, and terms which are already discussed while discussing the respective concepts in the lecture series. Thanks for watching this.
Like, share and subscribe. Hit the bell icon for more updates.